Welcome, ladies and gentlemen. Today we're going to talk about absolute value inequalities. So you're going to need your notes, a pen and or pencil, and a calculator, please. All right, our learning objective today is that you will be able to solve absolute value inequalities. Now, just as a reminder, an absolute value is the distance of a value from zero. So it's always going to be positive because we're talking about distance. Absolute value equations have an equal sign, and what we're going to talk about today, absolute value inequalities, we're going to have an inequality sign. So this kind of changes our approach of how we're going to solve this today. If we look at this absolute value inequality, we can think about what we did the other day. If we think about this as f of x equals absolute value of x minus 2. If we graph this, that means we're going to go to the right 2. We have a slope of 1. And our graph is going to look like this. Now, I'm going to bring in this less than 4 part. If I come here, I'm going to go to the y at 4. It's right here. What I'm looking at is what's less than, so what's below the line. And all of this and all of this is what is below the line. So if we look at this, I'm going from negative 2, to 6. So x has to be greater than negative 2, and x has to be less than 6. So we could look at it like this. It's going to be this. It's going to be in between these two. So if I write it in interval notation, it's going to go from negative 2 all the way to 6. All right? We're looking what's below. What part of the graph is below it? This is one kind of inequality. This is a less than. Now we're going to look at one that was going to be greater than. So if I think about what I've done already, I can do the same thing again. F of x equals absolute value of x plus 1. Do that part first. So I'm going to go to the left 1. Slope of 1, go both ways. So I make my v. Once I have my v, I'm going to look at this part here. It has to be greater than or equal to 3 this time. So I'm going to go to 3. There's my line at 3. Now it has to be above the line. What's greater than? So all of this or all of this. So I can write this one as what? X has to be less than or equal to, because that's what, negative 4. Or x has to be greater than or equal to, look, there's negative 4, here is 2. Okay? If I want to write these in interval notation, this is going on forever. So it's going to be negative infinity all the way to negative 4. That's where it's going to be. And I'm using this closed bracket because it's less than or equal to. Now this one, starting at 2 and then going all the way to infinity. Okay? Now we're going to start looking at these. We're going to do 3 more examples, but we're not going to worry about graphing them. Okay? We're going to try to figure out how to solve them without having to graph it each time. It's going to be very similar to when we use our equations. So if we look at this first one, first thing we have to do is set up 2 different inequalities. Very similar to what we did before. The first inequality is going to be 4x plus 5 is greater than 13. The second inequality is going to be the negative slope, so it's going to be negative times the quantity 4x plus 5 is greater than 13. Now we're going to go about solving both of these. So this one I'm going to go minus 5, 4x is greater than 8, divide by 4, x is greater than 2. So there's one. The next one, we're going to go over here and solve. First thing you have to do is get rid of that negative. I'm going to divide both sides by negative 1. So I get 4x plus 5. Now when I divide by a negative, I have to change my sign. So now it's going to be less than negative 13. Finish solving this, I'm going to minus 5. 4x is less than negative 18. Divide by 4. X is less than negative 4.5. So here are my two things. Once I have my two values, now I'm going to sketch it out on a number line. So if I look at this number line, on this side I've got negative 5, negative 4, and I'm going to do exactly what it says. So here I have to go x is greater than 2. So just greater than, so I'm going to have open circle at 2. And I'm going to go to the right. Now I have x is less than negative 4.5. So negative 4.5 is about here. And I'm going to go to the left. See how they're going away from each other? So when I write this, I'm going to write x is greater than 2, or x is less than negative 4.5. Okay, that's how we're going to write it when they're going apart from each other. In interval notation, if we look at this one right here, x is greater than 2, so here's 2, so I have an open bracket at 2, and then it goes on forever towards positive infinity, so it goes all the way to infinity. Or, if we look at the other one, I'm coming all the way from negative infinity all the way to negative 4.5, and then an open bracket. Okay? So that's how we write both of our answers. Alright, moving on to example number 4. We need to solve this inequality, so first thing we have to do is write it two separate inequalities. So I have x plus 4 is greater than or equal to 6. The other one I have is negative x plus 4 is greater than or equal to 6. Now I'm going to go and solve both of these. So subtract 4. X is greater than or equal to 2. On this one, I have to start by dividing by a negative 1. So x plus 4, when I do this, my sign has to switch, so negative 6. Solve this, minus 4 on both sides. X is less than or equal to negative 10. So here are my two answers. Now I have to sketch it out. So get my number line. And I'm going from negative 10 all the way to 2. So this time I'm going to have a closed circle because it's less than or equal to negative 10. So I'm going to be going to the left. Then I'm going to have a closed circle at 2. And I'm going to go to the right. So when I write this, it's going to be x is less than or equal to negative 10, or x is greater than or equal to 2. Now when I write this in interval notation, negative 10 to the left, that means I'm going all the way from negative infinity all the way to negative 10. This time we're going to have a closed bracket because we have that less than or equal to. On this one, I'm starting at 2. It's greater than or equal to, so I'm going to have that closed bracket at 2. That means it's including 2. And I'm going all the way to positive infinity. All right, there's example number 4. I have one more example for you, ladies and gentlemen. Example number 5. Here it is. So it says solve the inequality. I had the absolute value of x minus 7 is less than 1. So I have 2x minus 7 is less than 1. And my other one's going to be negative 2x minus 7 is less than 1. When I solve this one, I'm going to add 7. 2x is less than 8. Divide by 2. X is less than 4. Come over here, solve this one. First thing I'm going to do is get rid of that negative, so I'll divide by a negative 1. Get 2x minus 7. Have to switch my sign, is greater than negative 1. Add 7 to both sides. 2x is greater than 6. Divide by 2. X is greater than 3. So here are my two answers. Now I need to go about graphing it. So if I set up my graph, I've got 2, 3, 4, 5, x is less than 4. So I have an open circle at 4. I'm going to go to the left. Then x is greater than 3. So at 3, open circle, going to the right. Now, if you see, these two are going towards each other. They're never going to go past 3 or 4. When this happens, we're going to write it like this. We're going to write it as x is greater than 3 and x is less than 4. When they go together, we're going to call it an and. Now, if we write this in interval notation, we know we're starting at 3 with an open bracket because it's not colored in, it's only going to 3 but not touching it. And we're going all the way to 4. That's our interval from 3 to 4. All right, ladies and gentlemen, please make sure that you have all 5 of these examples written down in your notes, please. And that's all I have for you today, so I hope you go out and enjoy the rest of your day. Bye. See you later.